From the fantasies of Star Wars and Guardians of the Galaxy to the latest breakthroughs at NASA and SpaceX, space is pretty hot right now. Well, actually, it's pretty cold. But with space making headlines so often these days, chances are you've heard of TRAPPIST-1. It's an exciting discovery that could one day allow us to study and maybe even colonize other planets. But it also raises a big question. With today's technology, what would it take to travel to TRAPPIST-1? So put on your spacesuit and join us as we explore, in this episode of the Explainer Lab, how the hell are we going to get to TRAPPIST-1? TRAPPIST-1 is a planetary system located about 12 parsecs from our solar system, or roughly 39 light-years away. NASA recently announced that this system contains the largest number of Earth-sized planets ever discovered within the habitable zone of a single star. Its star is roughly 12 times less massive than our Sun, and at least 7 rocky planets orbit around it. Since these planets are outside our solar system, they're known as exoplanets. So why is this such a big deal? Well, astronomers have found that these exoplanets are remarkably similar to Earth, not just in size, but in mass as well. Due to their distance from their star and the star's relatively cool temperature, scientists believe these exoplanets receive amounts of light similar to some planets in our own solar system. NASA has reported that all 7 of these rocky worlds could potentially have liquid water, the key ingredient for life as we know it. That makes the TRAPPIST-1 system one of the best targets ever discovered for studying the atmospheres of potentially habitable, Earth-sized worlds. It's reasonable to imagine that one day we might be able to colonize one of the exoplanets in the TRAPPIST-1 system. But first, we'd have to figure out how to get there. Is it even possible? Well, since TRAPPIST-1 is 39 light-years away, it would take 39 years to reach it, if we could travel at the speed of light. Unfortunately, no modern spacecraft comes anywhere close to being that fast. Even if a spacecraft could travel that fast, we'd still have to figure out how to feed the crew for those 39 years. According to NASA, the average astronaut eats about 1.83 pounds, or 0.83 kilograms, of food per meal. That means each astronaut traveling to TRAPPIST-1 at the speed of light, eating 3 meals a day, would require nearly 67,000 pounds, or 30,390 kilograms, of food for the journey. But food isn't the only thing we'd have to worry about. Water is a major challenge too. On Earth, the average person uses about 35 gallons, or 132 liters of water every day. That's not just for drinking. It includes everything from showers to flushing the toilet. On board the International Space Station, though, astronauts have to limit their water use to just 3 gallons, or 11 liters per day, since water is incredibly heavy. Water on spacecraft is often produced as a byproduct of fuel cells. Simply put, fuel cells generate electricity by combining hydrogen and oxygen. But they don't just produce electricity, they also create water. That water is then recycled and used by the astronauts. Without fuel cells on a spacecraft capable of traveling at the speed of light, scientists would have to find another way to meet the crew's water needs. But since none of our spacecraft can actually travel that fast, we did some calculations to find out how long it would take us to reach TRAPPIST-1 with today's technology. One of the fastest spacecraft ever launched was NASA's New Horizons back in 2006. It flew past Pluto in 2015 and is currently traveling out of our solar system at around 32,000 miles, or 51,500 kilometers per hour. At that speed, it would take about 817,000 years to reach TRAPPIST-1. Alternatively, NASA's Juno spacecraft briefly traveled even faster during its approach to Jupiter, reaching around 165,000 miles, or 265,500 kilometers per hour. That makes it the fastest man-made object ever recorded. But even if a spacecraft could maintain that speed for the entire journey, it would still take roughly 159,000 years to reach TRAPPIST-1. Not to mention, neither Juno nor New Horizons was designed to carry people. NASA's Space Shuttle, on the other hand, could reach a maximum speed of around 17,500 miles, or 28,160 kilometers per hour while orbiting Earth. At that speed, the journey to TRAPPIST-1 would take more than 1.5 million years. Of course, a spacecraft's speed can vary depending on where it is in space, but none of today's technology comes anywhere close to making a trip to TRAPPIST-1 possible. One concept that could change that is the Breakthrough Starshot initiative. Championed by Stephen Hawking, the project aims to develop tiny, laser-propelled probes that could theoretically travel at up to 20% the speed of light. With technology like that, the trip to TRAPPIST-1 could take as little as 200 years. But we're not there yet. And even if we were, the project is designed to launch a tiny probe weighing about as much as a paperclip and roughly the size of a postage stamp. Maybe Ant-Man could squeeze in there, but the rest of us definitely couldn't. With today's spacecraft and technology, there's simply no way anyone could reach TRAPPIST-1 within a single lifetime. Maybe the future will bring us a way to get there, but for now, it's probably best to hold off on planning any interstellar vacations. Oh well, at least we'll still get to explore the galaxy when the next Mass Effect comes out. So, what do you think? Will humanity ever reach TRAPPIST-1, or is it destined to remain just another distant point of light in the night sky? And if we do become an interplanetary species, do you think Mars will be our first true home? Let us know your thoughts in the comments. We'd love to hear your take. If you enjoyed this video and want more fun, easy-to-understand deep dives into science, space, and technology, be sure to like the video, subscribe to the Explainer Lab, and turn on notifications so you never miss an episode. Thanks for watching, and we'll see you in the next one.